Hello. In this video, you are going to learn about the properties and operations of polynomials. To begin, let's review combining like terms. Suppose we have the polynomial 2x squared minus 6y squared plus 3x squared minus 12y squared. So I see 2x squared, and its like term is 3x squared. There's a plus in front of 3x squared, so it's going to be 2x squared plus 3x squared, which is 5x squared. Then I see my negative 6y squared and a negative 12y squared. Negative 6y squared minus 12y squared is negative 18y squared. And just as simple as that, I've combined like terms. Classifying polynomials. To classify polynomials, you're going to count the number of terms in a problem and determine if there's 1, 2, 3, or 4 more. If you see one term such as 3x squared y, that's what we call a monomial. Mono, one, monomial. If I see something such as 2x squared plus 3x, there's 2x squared and 3x, meaning there are two terms, so I call that binomial, just like bicycle. Bicycle has two wheels, a binomial has two terms. Three terms such as 4x squared plus 2x minus 1. 4x squared is one term, 2x is another, minus 1 is our third term. Since I have three terms, it's called a trinomial. Just like a tricycle has three wheels, a trinomial has three terms. And then anytime I have 4 or more terms, that is what we refer to as polynomials. So negative 2x to the fifth plus x to the fourth minus 3x squared plus 1. That expression has 4 terms, therefore it is referred to as a polynomial. Now, we can also classify these different polynomials with using their degree. So a monomial is a little bit different than the other one, so we're going to look at that one specifically. When you see a monomial, you're going to sum all of the exponents. For example, if we have negative 3m to the 8, n to the 4th, x squared, y to the 6th, that is all one term. And I see these 4 exponents, 8 plus 4 plus 2 plus 6. Adding all of those together, I determine that this monomial has a degree of 20. But what about degrees of polynomials? Well, in that case, you're going to find the highest power of the polynomial. So let's look. 3x plus 1. I understand that x has a power of 1. Therefore, we refer to this as a linear polynomial. A linear binomial, actually, because it only has two terms. A linear expression. We've seen linear expressions frequently, and we've even seen them already this school year. Okay, now 2x squared plus 3x. 2 is my highest power. This is squared, so we refer to this as a quadratic. And we just finished working with quadratics in our last unit, so we should be very familiar with these as well. 4x cubed plus 2x minus 1. 3 is our highest power, so that's going to be a cubic function, or a cubic expression. Negative 2x to the 4th plus x cubed minus 3x squared plus 1. 4 is my highest power, so we refer to this as a quartic function. And lastly, 3x to the 5th plus 2x squared minus 5. 5 being my highest power, and that's going to be a quintic function. Now, on all 5 of these examples, our leading term, meaning the term in the front, was in the highest power, or was the highest power. This is what we call standard form. As we begin working through these problems, it may be necessary to arrange your expression or your equation in standard form, meaning the highest power comes first, and then it decreases all the way down to the least power, greatest to least, so that you don't have any issues classifying the polynomial. We'll see that in an example. We're going to classify this polynomial. 4x to the 5th minus 7x to the 10th plus 9x to the 4th minus 2x cubed plus 3x squared. The first thing I want to do is write this in standard form. Well, my negative 7x to the 10th power is my largest polynomial, so it's going to go first. And then the rest were already in order. Plus 4x to the 5th plus 9x to the 4th minus 2x cubed plus 3x squared. Now, I'm going to count the number of terms. I see negative 7x to the 10th, 4x to the 5th, 9x to the 4th, 2x cubed, 3x squared. I'm sorry, that 2x cubed is negative. So that is a total of 5 terms. I also want to determine my highest power, which in this case is 10. So my degree is 10. Because it's 5 terms, we refer to it as a polynomial. And 10 is just really high, so we don't have a special word for that. So we're going to refer to it as a 10th degree polynomial. Let's look at another one. We're still classifying the polynomial, and part B says 6x to the 4th minus 5x cubed plus 9x squared plus 7x minus 6. Now this one is already in standard form, so we're going to begin by counting the terms. We have x to the 4th, x cubed, x squared, x, and then just a regular constant. And that is a total of 5 terms. Then we're going to find the highest power. In this case, it's 4, so our degree is 4. Therefore, this is a quartic polynomial. Quartic because the power is 4, polynomial because there are more than 3 terms. There are 4 or more terms, in this case specifically 5. Let's look at adding 2 polynomials together. We have 5x to the 5th minus 3x squared plus 7x squared minus 2x to the 5th. Now, each separate polynomial is grouped. 5x to the 5th minus 3x squared, that's 1. And then my other one is 7x squared minus 2x to the 5th. Anytime I'm adding, it is very similar to, or it is the same as, combining like terms. So I have 5x to the 5th minus 2x to the 5th. 5x to the 5th plus a negative 2x to the 5th is equivalent to saying 5 minus 2, which is 3x to the 5th. Then I see, I'm going to bring down the plus because it's adding. Then I see negative 3x squared and 7x squared. So negative 3x squared plus 7x squared is going to be 4x squared. Let's go ahead and classify this polynomial. It has 2 terms. And the highest power is 5. Therefore, this is a quintic binomial. Quintic because the power is 5, binomial because they are 2 terms. What about subtracting polynomials? Well, this is very similar, except there's going to be one additional step. Before I begin subtracting, I'm going to distribute the negative so I don't make any calculation mistakes. So I have 5x to the 4th minus 3x squared minus 7x squared plus 2x to the 4th. At this point, I'm back to the same as our previous example by combining like terms. 5x to the 4th and 2x to the 4th is 7x to the 4th. Negative 3x squared and negative 7x squared is negative 10x squared. So this one, our power is 4. It has 2 terms. This one is called a quartic binomial. What about multiplying polynomials? 5x to the 4th minus 3x squared times 7x squared minus 2x to the 4th. I'm going to take 5x to the 4th and distribute it to the 7x squared, which is 35x to the 6th. 5 times 7 is 35. X to the 4th times x squared means I say 4 plus 2, which is 6. Remember, I multiply coefficients and add the powers whenever I'm multiplying 2 terms together. And you should have learned that in Algebra 1. Honestly, you should have learned it before Algebra 1. Then I'm going to take 5x to the 4th. I'm going to multiply it times negative 2x to the 4th. So 5 times negative 2 is negative 10. 4 plus 4 is 8. Be very careful. Do not say 4 times 4 is 16. That would be incorrect. Now I'm going to take negative 3x squared and multiply it times 7x squared, which is negative 21x to the 4th. And negative 3x squared minus 2x to the 4th, which is going to be plus 6x to the 6th. Now, my next question is, are there any like terms? Yes, there are. I have 35x to the 6th and 6x to the 6th. That is simplified to 41x to the 6th. There are no other like terms, so I'm going to bring the remainder of the polynomial down. Then I'm going to go ahead and write this in standard form. So that means my negative 10x to the 8 needs to be in the front. So I have negative 10x to the 8th plus 41x to the 6th minus 21x to the 4th. So I see my powers are decreasing 8, 6, 4. Therefore, it's in standard form. Let's go ahead and classify this polynomial. It's an 8th degree trinomial. eighth degree because the highest power is 8, and trinomial because there are 3 terms, x to the 8th, x 6th, x to the 4th. So that concludes our video on simplifying polynomials.